My name is David Cash. As I mentioned, I'm one of the technical occupation specialists here at Mountz. I've been in the torque tool industry for nearly 20 years now, and I've had the opportunity to see some really amazing applications. Through my tenure at Mountz here, I started as a territory sales manager. I've been a product manager and currently part of the marketing group as a technical application specialist. So it's really good to be here with you today. Again, sorry for the late start. So to get a little information about Mountz. Mountz began in 1965 in this garage here. We then moved to our current corporate and service center facility in the heart of Silicon Valley. Mountz was the first company to develop an electronic torque tester for the United States military. We do have our warehouse and distribution and Eastern Service Center in the Gulf Coast of Alabama to be able to service you there well. So that gives you a little info on Mountz. So today's topic we're talking about obviously is calibration and how we can tell when a tool is going out of its calibration. And so if we talk about what torque calibration is, it is a standard process to document and ensure repeatable accuracy from tools used to apply torque during the fastening process. And so basically, it's a process that makes sure that the tool is performing to the specifications that the manufacturer has set forth. It gives you documentation and traceability to the performance that's happening with the tool. And it also makes sure that the tool is actually performing the way it is supposed to. So if we look at establishing a calibration regimen, we're going to go ahead and ask our poll question for today. And let me know what your organization does for its calibration schedule. Do you do it on a 6-month period, every 12 months, or is it done by cycles, or is it done, or you just don't are unsure of what that is? So go ahead, you can populate the poll question there, and we'll go ahead and see what our results are. All right, we're getting about halfway through the participants here. All right, and it looks like the majority of the responses are every 12 months. There's a few that are every 6 months, even fewer that go for total cycle count. And then roughly 20% or so that are unsure. So I'll go ahead and end this here, and I can share the results with you on what the actual poll presented here. So fantastic. All right. So if you look at the calibration equipment that's typically used for calibrating tools, it's going to be a torque analyzer with a reaction transducer. In this example, there's a unit that has the display with it. We also have available units that are handheld. And there's also other transducers like a rotary dynamic transducer. These are typically used in conjunction with an inline application. So you put your tool in between your application, and this is going to actually read what the torque is going to be on your application. And that's probably a whole nother webinar in itself with that. So, but that's the basic calibration equipment that's used for calibrating torque hand tools and also power tools. So if you were to send your tools into Mountz for calibration, this is kind of uh, the journey for your specific tool. So first, the tools are received in. They are then immediately given a bin location. So that tool is now married to that bin for its existence during the calibration cycle. So at any time, if the tool needs to be located, we'll know exactly where it is and how to locate it. Uh, Next, that tool is then given an order number, so that it is generated through our system. All of the details regarding what calibration it is are all entered in. Then it becomes an order to be sent to the calibration lab. So at that point, there's going to be some testing and adjustments that are done. Um, with the depending on what type of tool it is, whether it's a hand tool or if it's a torque analyzer. Um, the So for example, if we're going to be doing an analyzer, this kind of just gives you a little bit of the process here. Typically, you would be having the analyzer with a wheel uh, at a determined length, and then you're going to be adding weights to it to calibrate it at certain set points for the analyzer. So that's how typically analyzers are calibrated as compared to the hand tools. The next step in the journey is the calibration certificate is then generated. The technician will go ahead and input the data from the test. They will put in the as found data along with if there were any adjustments made to the tool, what that adjustment was, and then it will go ahead and print out the calibration certificate. It'll also generate the label for your tool. That's going to have basically the ID number. It will also contain when the calibration was done, when it's due, also the service technician that did the calibration as well will be put on the tool. And then at that point, it goes to final quality inspection to make sure that it was done correctly to the order. And finally, it's then ready to be shipped and sent back out to you. So at this point, the calibration has been done. The tool comes back to you, and then at this point, this is the issue where the quality challenge can come into effect. So, and that would be dealing with tools that have drifted. So if you get your calibration certificate back and it has a as found in state that was out of your tolerance, that can really be a big issue. If it was out by a lot or out by a little, that may be determined some significant ramifications that can be attributed to items that were manufactured and used with that specific tool. So at what point did the tool go out of calibration between cycles? We really don't know. So that's the real quality challenge here, and that can also become a liability as it relates to items that tool worked on. Would it be for parts that are going to be used by another manufacturer in their end product? And then if there is time and cost associated with any type of rework that's going to be done for that specific tool. So this is basically the quality challenge as it relates to being able to keep your tools within the calibration. So what can we do to help mitigate this? The process that we can put in place, it would be a torque verification process. This is going to be items that are going to help to improve your quality. It's going to reduce the liability, and it's going to save you time and money. So with the torque verification process, it's basically giving you the ability to test your tools at any point to make sure that they're still within their calibration. So let's second here. So having this process in place, it's really going to help in with your continuous improvement, being able to mitigate any type of tool that may have any type of maintenance or repair issue to it. So you can really be able to spot problems before they become a huge issue that may cost a lot of time and money to go ahead and fix. So the equipment that you would be needed to do a torque verification for on-demand testing, it would be a torque analyzer that is portable, that you could use, that would have a battery with it. It could either be a handheld unit, or it could be either an analyzer that could be mounted to a cart or a bench for specific higher torque readings that may need to be taken. Obviously, it would need to be ISO certified. If it has the ability to issue a pass-fail assessment, and also be able to collect data, store that data, and be able to provide you with any statistical analysis as well. That's the equipment that you would need to do the torque verification. So implementing a torque verification program, you're going to need to do these things, or determine the program interval. So would you like to test your tools once a week, once a month? Maybe it's once a shift, maybe it's at the beginning of the day, at the end of the day. Whatever interval is going to work best for your QMS system, that would be acceptable. Now, this can be done either by an operator, like I said, at the beginning of the shift, or you could have dedicated personnel to do that. At that point, you'll need to design what the test procedure is going to look like. How many rundowns are you going to take? Is it going to be 10, 5, 20? Just to make sure that the tool is still performing at the requirements that you need. And then a process for tools that fail that process. Where's that tool going to go? Will it be going to repair? Is it going to be sent out for calibration? Or is there another party that would be taking a closer look at that specific tool and then make some adjustments to it? So that's kind of the implementation process and things that you would want to do. So now, if you're conducting a routine torque verification, some certain things that might help the process would be using an analyzer that would have a preset torque value target that you can either enter in, or you can have it visually pull up on the screen to give you a quick pass and fail feedback feature. It's going to record the results for you, and then also you could flag that tool for service at that particular time. Just to kind of give you an idea of what is available that you can do with that. All right, so if we take a look at this analyzer, this is our Easy Torque 3 analyzer. What this does, obviously, it gives you the ability to, you can set your torque value, a preset torque value that you might need. You enter in a tolerance. It will then give you your min and your maximum values, tell you which mode that you're in peak mode. The screen itself gives you a visual demonstration of where the good and no good ranges are. So at 12 o'clock there, you'll see the green area. This gives us the acceptable area for testing. So if we were to go ahead and test our tool here, this system does come with a with an SD card that is inserted into the side of the unit. It will go ahead and it will save all of the readings that are taken on here. So if we wanted to include a serial number with that, we could do that by going into the settings menu. We could enter in a serial number for that particular tool. And now the readings that are taken will be linked to this tool. So if we take some readings, so now all of those readings have been saved. The SD card then can be removed, and it will then go ahead and display all of the torque values. So I did some rundowns a little bit earlier today before we started here, and with this same tool, this is all of the information that that is gathered from the analyzer. So in column A gives you the tool serial number. Column B gives you the rundown that was taken. C gives you the result if it was within spec or out of spec. The time for column D, which mode we used, peak mode, the torque values that were given, and then it starts to go ahead and compile some statistical data all the way down, providing you the CM and CMK numbers along with the min, max, and the standard deviation for the final reading there. So that is one way that you could do this. This particular analyzer is portable. It is very compact. It does have mounting holes here that you can spring loaded, that you can mount these down onto a cart or a bench if needed. So next we would have our let's see here, our LTT product. Let's go ahead and set this up. Let's make some adjustments here to the focus. Okay, so with this unit, you do have the ability to store your readings. You also have the ability to add tool tests. So in the software that comes with it, you can go ahead and set up a tool test that's designed for a specific tool. There are a number of different ways that you can pull that tool test up. So if I just go ahead and I select tool test here, and we can go to select, and I have an NF series tool right here that we can go ahead and do our test with. So now that we've selected that tool test, it does have specific parameters that are set for that. So the tool is set to 5 inch-pounds, and we're going to be taking 5 readings. So we can go ahead and start the test. All right. Okay, so it took our 5 readings, and then it saved that specific test with there. So sorry, I did misspoke. It was set to 6 pounds, 6-inch pounds, not 5. So then the operator can then come back to the unit and hook that up to your computer system, and then you can download the results from that, and it can give you a readout of all your readings for that specific tool. Gives you the time, the date it was stamped, and then all of the readings that were associated with that specific tool test. You can have up to 100 tool tests on the LTT, and be able to do on-demand torque testing with it. You don't have to use it with the tool tests primarily, but you can use it as long as you're within the range of the transducer. All right, now it's time for our questions and answers. And I think we'll go ahead and bring Chris Morris, our marketing manager, into the discussion to go ahead and give us some of the questions that came in, and we'll see what we can do to answer those.
All right, Dave. The first question we have is, do torque analyzers, torque calibration equipment need to be calibrated? How and why not?
They do need to be, sorry, morphine here. Yes, they do need to be calibrated. They could be calibrated on a either 6-month, 12-month, or 18-month calibration cycle, just like the normal torque tools would need to be calibrated. So yes, those do need to be calibrated as well.
Okay. Another question we got, I think it was during the Easy Torque part of the demonstration, was, does this device have a hard reset button?
A hard reset? I guess only powering it on and powering it back off, or powering it off and then powering it back on. If there is, I'm not sure but we can certainly try and find out.
Okay. Next question was, what is a good threshold percentage to identify a tool drifting out of tolerance and trigger it to be recalibrated?
So, excuse me. So that would be determined by the process or the, I guess, requirements that you would require for your specific application. So if 10%, plus or minus 10% of the torque value is the value that you want to go with, then you could set your tool up to make sure that it stays within that tolerance. So, and that could fluctuate anywhere from 5% to 6, 10, 15. It just depends on the application and how critical the torque is for that specific joint. So it would be determined by your specification for your specific part.
All right, next question would be, is the amount of use of the tool determine a 6, 12, or 18-month schedule, or is there something else that determines the schedule?
So the schedule, again, can be determined by usage. So for hand tools, example, that are ISO 6789, those must meet at least 5,000 cycles before they need to be recalibrated again. So that would be one point that you could look at a specific tool and the number of cycles that it would be completing within a certain run of its use, and you could calibrate it that way. You could also basically monitor a specific tool and see how it performs. But for most time, it's going to be determined by what your process and what your company deems acceptable. 6 months or 12 months And then we also have customers that don't necessarily send their tools in for calibration based off of the time, but they base it off of performance. So they do a rigorous torque verification testing protocol. And so they monitor those tools very closely. Once they see a tool that is drifting out of calibration, at that point, then that tool is then removed and then calibrated at that time. So that tool could potentially be there longer than 12 months. It could be there longer than 18 months, as long as it's still performing within its torque specification and it's still meeting the torque verification protocol, then that tool can remain in service. So the ISO certificate that that comes with the torque analyzer is then giving that specific tool the traceability and documentation that it needs to be remain in calibration.
All right. What is the main difference for calibration and verification concepts?
Sorry, Chris, one more time.
What is the main difference between a calibration and the verification concept?
Well, the concept is very is almost identical. You're taking a tool that has been on the line, or you're testing it while it is online, and you're seeing what is the torque output that the tool is producing. That's the same thing that you would be doing for the calibration process. The only difference is with calibration, then you would be adjusting the tool to meet the specific requirement if it's not meeting it already. So the verification part of it is testing the tool to make sure that it's still within its specification that you've have required for the torque output. Then the calibration part of it would be the actual adjustment of the tool if it's not meeting it. So the verification process could then, if the tool is out, again, that would be, you would remove that tool, replace it, and then have it calibrated and recertified.
All right. Next question: how often do torque analyzers need to be resent in for calibration?
Analyzers can be typically it could be 6 months. We have some customers that will do it on a 12-month annual basis. I would say the majority of the customers do it on an annual basis. And then we do have some other customers that will extend that out to 18 months as well.
Does a tool need to be recalibrated after it's been dropped?
A tool may not necessarily have to be recalibrated after it's been dropped. However, it should be tested on an analyzer to make sure it's still meeting its spec, especially with a tool that would be sensitive to those types of issues. Typically a click wrench, maybe not so much an internal cam over type screwdriver, but if a tool is dropped, it most certainly should be checked on an analyzer.
All right, I think that was our last question, David.
All right, very good. So I just want to again say thank you very much to everyone that joined us today. We really appreciate your feedback on the session. You will be getting information emailed to you regarding things that you liked, maybe things that you think we can improve on, possible topics for future webinars that we have. We do have some more in the pipeline coming, so any feedback that you can give us would be fantastic. We really appreciate that, and we look forward to seeing you next time. All right, thanks so much.